Okay, so this warm-up is not in your packet. We are going to pause the video here for you to try these 3 problems. Make sure you use your knowledge of transformations from all of our prior units to talk about what these different values do to the graph. It should take you no longer than 4 or 5 minutes for the 3 problems. So for number 1, the 3 is a vertical dilation of 3, and the 2 shifts us down 2. For number 2, the negative leading coefficient is a reflection over the x-axis, and the positive 4 is up 4. And then lastly, for number 3, the 1/2 is a horizontal dilation of a half. Okay, so we're going to start on this page in your packet. I'll give you a minute to find it. And we're going to be focusing today on graphing sine and cosine functions with their transformations, and specifically talking about the period, the midline, and the amplitude, and how the transformations affect those 3 properties. So before we start number 1, which is, and number 2 and 3, which are sine functions, let's review the parent graph for a sine function. We have all the quadrantal angles, so the last is 2 pi, pi, and then pi over 2, and 3 pi over 2. And if you remember, sine started at the origin because the y value is 0 on the unit circle at 0, and then went to 1, which is the max, back to 0, back to the minimum, and back to 0. And as you can see, we have 5 points each time. So the pattern for the sine graph is middle to max, back to middle, to minimum, to middle. And we're going to use those 5 points, those 5 critical values, for graphing every single function now. So if you look at number 1, it says graph 3 sine of x. So before we even start, what does a 3 do? Okay, it's the vertical dilation of 3. So what happens is, instead of the amplitude going from 0 to 1, a maximum of 1, now we're going to start at 0 and go to 3. We've stretched it vertically by 3. And now the minimum goes to -3. So we have one period of our sine graph, vertically stretched by 3. So the maximum is now 3 and the minimum is -3. So for number 2, when the equation is changed, what impact does it have on the graph? So we're going to say a vertical dilation of 3 changes the amplitude to 3. So now for number 3, we have 2 plus sine of x. Well, we know that plus 2 is a vertical shift or a vertical translation of 2. So I'm going to do a dashed line at 2, because what that helps me is keeps my eye is that 2 now is going to be our midline. So instead of the x-axis being the midline, the midline y equals 2 is our midline. Now using our 5 key points, we've got middle, maximum, middle, minimum, and middle. Notice the amplitude didn't change. There's still a 1 in front of sine of x as a coefficient. And there's our sine graph shifted up 2. So now answer number 4. What change did the plus 2 have on the graph? Describe the key features using a word, amplitude, period, or midline. Okay, so your answer should say something about a vertical shift of 2 changes the midline to y equals 2. Okay, so let's try it again with graphs in 5 and 7. So the graph of 5, we have sine 2x. So stop for a second and think, what does this 2 transformation do? We said in the warm-up that was a horizontal dilation. So now what's going to happen, because we have the horizontal dilation, our period is going to change. So instead of doing 1 rotation in 2 pi, we're going to have a different period. This dilation value, we're going to call it b. So when you want to find the new period, we're going to take 2 pi and divide by b. So in this case, 2 pi divided by 2 is now pi. So what's going to happen is we're going to get a whole period in between 0 to pi. Now we have 5 critical values. If I count from 0 to pi, we have to split that into 5 equal sections. So we have 0, pi over 2, and pi. That's 3 points. So to get 2 more, we're going to go halfway of each. So we have 0, and now we can think, what's half of half? Or what's half of pi over 2? This is going to be at pi over 4. So when we count, we have 0, pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. Because the directions say graph from 0 to 2 pi, I'm going to include the other pi over 4 points. So let's see, that's 3, 4, so this is going to be 5 pi over 4, 6 pi over 4, and then 7 pi over 4. There's no amplitude change, there's no midline change, so now we have middle, max, middle, minimum, middle, and then repeat the pattern, max, middle, minimum, middle. And connect your points in a nice wave. So if you answer number 6, when the equation changes so that it's sine of 2x, what effect does it have on the graph? And make sure to use one of the key features, amplitude, period, or midline change. Okay, so it is a horizontal dilation of 2, which changes the period to pi. Okay, so try number 7. You have seen both changes before in this lesson in the video for number 7, so see if you can get a graph before I graph it. We'll pause the video here so you can do that. So the graph went up 1. So my new midline, so the midline changes to y equals 1. And the amplitude is now going to be 2 because of the vertical shift of 2. So I start in the middle, go to the max. Notice I went a vertical distance up of 2 from the midline for that amplitude. Back to the middle, down to the minimum, and back to the middle. So each maximum and minimum is 2 units away from the midline. And there's our graph. So now if you look at numbers 9 and 10, instead of the sine graph, we have the cosine graph. So let's review the parent function for cosine. So cosine has the same period of 2 pi. And the x value at 0 radians, on the unit circle is 1, so we're at a maximum. Go to the middle, and then the minimum, and then the middle, and then the max. So we have the pattern of max to middle to minimum, back to middle, and ending at a maximum. So those are our 5 critical values, our 5 key points when we graph the cosine function. Okay, so for number 9, it says we have a horizontal dilation of 1/3. Now, if you look back at our horizontal dilation before, we had that coefficient of 2, which gave us 2 periods. Now we have a horizontal dilation of 1/3. So if we want to find the new period, I'm going to do NP for short, we do 2 pi divided by 1/3. Well, that's a fraction within a fraction. To simplify that, we're going to multiply by the reciprocal of the denominator, which is 3 over 1. So our new period is 6 pi. The directions say graph over 1 full period. The graph paper they give us does not really help with that. So I'm going to change the scale. I'm going to call this last value 6 pi. Now, to label this point, what is halfway between 0 and 6? That would be 3 pi. What's halfway between 0 and 3 pi? If you want, you can say 0 plus 3 pi divided by 2. So that would give us 3 pi divided by 2, because halfway is the midpoint, so if you add them up and divide by 2. We can do the same thing with this last key point. What's halfway between 3 and 6? So 3 pi plus 6 pi is 9 pi, and then divided by 2. So now we have our graph paper labeled for 1 full period, so we can graph with this. Oops, I started in the wrong spot. It's a cosine graph now. So now we can graph with this change of period on this graph paper. Typically, 2 pi would be about here. So you can see how we have that horizontal stretch of 3 from the dilation value here, that coefficient of 1/3. So we are getting a third of a period in where we would normally get 1 full period. So for answering number 10, what changes? So that was a horizontal dilation of 1/3, which if you use the other words, it's a stretch of 3, and it changed the period to 6 pi. So instead of 2 pi, we've stretched it 3 times now to 6 pi. Okay, you try 11 and 12 based on what we did earlier with that coefficient in front of the cosine function, or in front of the sine function. It's the same transformation. So that's a vertical dilation of 1/2, meaning our amplitude is 1/2. So our maximum now is at 1/2, and our minimum is at -1/2. Oops, I put that in the wrong spot. Goes over here on pi. I did it again. Hang on. Sorry about that, guys. All right, let's start over. We've got maximum, middle, minimum, middle, maximum. So as you can see by now, the maximum being at 1/2 and the minimum being 1/2, this vertical dilation is a shrink of 1/2. Okay, so let's do 2 more. We're going to pause the video here. You try 13, 14, 15, and 16. And then we'll unpause it so you can check your answers. So for 13 now, the midline has moved in down 1 to y equals -1. So I'm going to put this little dashed line to help my eye know that that's the midline. My amplitude is still 1. And there's our cosine graph shifted down 1. Now 15, our midline moved up 1 to y equals 1. And we also have a period change because there's been a horizontal dilation of 2. So the new period is going to be 2 pi divided by 2, which is pi. So I have to add in my pi over 4 scale again. That's a period of pi because of the horizontal dilation of 2. So let's see, we have maximum, middle, minimum, middle, maximum, middle, minimum, middle, maximum. And there's our 2 periods. In 2 pi, we got 2 periods of the cosine function because of that horizontal dilation. Now we're going to go the other way. Given a graph, we're going to write one sine function and one cosine function. Looking at number 1, for the amplitude, I can see our maximums here at 4 and our minimums at -4, meaning the midline is at y equals 0. Sorry, that's a little messy. The amplitude is 4. And now we have to pick sine and cosine graph function. So let's start. I'm going to look for my key points. And I know that the sine function starts in the middle and goes to the max. So if I start with the sine equation, there's been no vertical change. So you can do +0 to hold your spot. One thing I didn't check, Miss Weiss, you need to make sure to check for the new period. So I can see our period goes from 0 all the way over to 6 pi. So if our new period is 6 pi, the value in our equation is going to be that b value. So if we isolate the b, we're going to get 1/3. We have 1 period in 3 times the amount. So that's a 1/3 x. Now for the cosine function, we want to look at where a maximum starts, and that's right here. And now we have a shift to the right. So when I go to write my cosine function, everything's going to be the same, except I now have a shift to the right. So that's minus some x value. Let's see, what is halfway between pi and 2 pi? We can find the midpoint, add up the values, so pi plus 2 pi is 3 pi divided by 2. That's one answer. We could also do a reflected cosine graph. So there's infinite answers for every function that you're going to write an equation to since the pattern keeps repeating. So if I wanted to do a reflected cosine graph, I could look at the minimum, find this x value, which is going to be 9 pi over 2, and I could write a cosine function as negative cosine, move to the right, 9 pi over 2. I personally prefer, instead of doing a reflection and a horizontal shift, would rather do a maximum so that there's no reflection and take into account the horizontal shift. Okay, so let's try it again for number 2. Let's list out our amplitude, period, and midline before we start. So go ahead and fill in those three properties. We'll pause the video and give you a minute to do that. So I can see my amplitude goes from 1 to 2. That's an amplitude of 1. The midline is y equals 1. And a period is pi. So to get the b value, if the new period is pi, I have to isolate that b value for my equation. We don't put the period in as our horizontal dilation. You have to find that coefficient. And you can see we get 2 periods in the space of 1. So my b value is 2. Now to write my equations, I notice that this graph starts at a maximum. So that's going to be a cosine function, not shifted left or right. Now you could do a cosine function at this maximum, so if you wrote this equation shifted to the right pi, you're still correct. You could even write one shifted over here at 2 pi. It is okay if you don't write this coefficient of 1, because when you multiply by 1, nothing changes. Now for my sine function, I have to figure out where my shift is. Sine starts in the middle and then goes to a maximum. So here's the first time that happens. We're at the middle, go to a max, back to the middle. So I need this x value. Halfway between pi over 2 and pi is 3 pi over 2. Now, because I did it on the last problem, I'll do it on number 2. I could do a negative sine graph where it's been reflected. So a reflection of a sine graph, instead of going middle to maximum, would be middle to minimum. So if I did a negative sine graph, I could say it's been reflected and then move to the right some value. So halfway between 0 and pi over 2 is pi over 4. I could have also chosen this value as a reflected sine graph, reflected over the x-axis. Okay, so you try 3 and 4. We'll pause the video here to give you time to do those. Okay, so for 3, my amplitude looks like it's 5. My midline is y equals 0. And the period, looks like we start at negative 9 pi and go to 9 pi. So that's a period of 18 pi. Wow, that's really stretched out. So the new period is 2 pi over the b value in my equation. So when I isolate b, I get 1/9. Okay, so one possible answer would be 5 cosine 1/9 x. Here's my amplitude change, here's my period change. No horizontal shift because this is the maximum, and no vertical shift because we have a midline of y equals 0. Now for a sine function, here's where we start in the middle and go to the maximum. Oops, sine. And that's now to the left 4 pi. Remember, there's infinite answers. You could have also done a negative sine function, so reflected to the right 4 pi. You could have done a reflected cosine function with either minimum. When we grade your test next week, we will know all the different possible answers you can write from a graph and grade your graphs appropriately. Okay, and lastly for number 4, the amplitude is 1. The midline is at y equals -2. And the period, we go from -pi/3 to pi/3. So pi/3 plus another pi/3 makes that 2pi/3 for the period. So 2pi/3 equals 2pi/b. That means our b value is going to be 3. So I'm going to start with the sine function since here's our middle. You don't technically need those parentheses. You do need them for the horizontal shift, like this cosine to the right. That's to the right pi/6. It doesn't hurt to put the parentheses here when there's no horizontal shift left or right, but you don't have to. It's okay. All right, so your homework is page 29 and 30. If there's any time left in class, you can start it now. We are aware that there are infinite answers to each graph. When you check on Edline, I've only included the answers, one answer for each equation. If you want to check your specific answer, please come see your teacher at lunch the next day, and we'll be happy to make sure your specific equation is correct or it can match the equation that's posted on Edline.